it's like a one problem warm up. So you could just find a place in a corner somewhere. If you could please add, let's see what it'll be, 1/6 plus 7/15. Yes. Oh yeah, that's it. Checking the neighborhood for Okay, so for common denominator, did you multiply top and bottom of this one by 6? You could, but instead you probably multiply top and bottom by 2, and then of course for the first one you multiply top and bottom by 5. Why did you choose that? Right, the least common multiple of GCF, those terms I know that get confusing. The least common multiple. Are we good with that? Yes,
It's
man.
not just easier to like say 6 times 7 is 15 times 1 and then add them together and multiply them and then simplify.
You could do that. That'll always be fine. So that's just multiplying by 6, basically multiplying by 15. Right? I don't like to just do stuff unless it's a property. Like here, I'm using the identity property of multiplication. But you're right. That would work for sure. But what I'd like you to think about, actually, before I want you to think about this, right? How did you get that least common multiple? Would anyone like to explain what they did? And for me, like I remember when I was in school, I kind of went through a quick list in my head. What's the next 24, 30, and then was kind of figure it out. Maybe some of you did this, and okay, there's 30 right there. Maybe you just kind of figured it out. Maybe you didn't do all the 12, 18, but just now you get there. And that works. But what I'd like you to think about is let's break this up into factors. The factors of 6 are just 2 times 3. The factors of 15 are 3 times 5. We need to make sure that the denominators are the same, which means they have to have the same factors. So do you see how we could get that to happen without much more consideration? Like in the first one, we have a 2 and a 3. This one has a 3 and a 5, so all I need to do is multiply top and bottom here by 5 for that first one. As opposed to the second one, we're just going to multiply by 2. In fact, the 30 doesn't even come to mind if I'm breaking down the factors. It just pops out. Does that make sense? It's kind of a way to think about this. Different, maybe, from what you do. What's that?
Can you explain how you found it?
Oh, sure. I want the denominators to be the same, and the only way I could do that is by multiplication. So I see there's a commonality. Like when I'm looking at the I see there's a commonality of 3. So I'm also going to put a 5 here, so we can both have 5s. Like if I do this, we're good for the first one. But the second one has to be adjusted still because it has common denominators. This is missing a 2. So I just multiply top and bottom by 2. Now we can see that the denominator is 30, but it wasn't like I had that 30 as a goal. I just had common denominator, lowest common denominator as a goal. We could have done a similar thing just by multiplying top and bottom by 15 here, multiplying top and bottom by 6. Right, they still have the same denominator, but they're repeats. It's not the lowest common denominator. It's not the least common multiple that we're talking about here. This will work, but you're going to have to simplify at the end. It's what I call the scenic route. Instead of going directly to the answer, you continue going this way and then get it back to it. So let's keep that in mind today as we go through adding and subtracting rational expressions. They give us a whole lot of space there. I'm just going to say you must have, it's an M. You must have common denominators. I know that's really helpful information for you. You didn't know that. Mind blown. I know. Preferably. Least common denominator. Least? Lowest? Lieberman? I don't know what that else stands for. Probably not Lieberman. That doesn't make any sense at all. So A. Hey, it's already common denominator. Yay, go ahead and finish A. Check in with your neighbor when you finish. Did they get it right? So they both have a common denominator of x squared minus 9. Top becomes x plus 3. Did you get that plus 3? Because if you didn't, that's going to hurt you all year. Subtraction of a quantity. You have to subtract the whole quantity. So make sure you're distributing through. So now just cancel the x's and the 3. Is that how that works?
No.
No, you can only cancel. What's the word you can only cancel? That's an F. Factors. So x squared minus 9. We know we could factor that into. It's like poetry. And now we have a common factor. Get out of there. So we have 1 over x minus 3. Done with that one. B. Okay, so we have what? Negative 2x minus 2 over x plus 1. Factor out. Negative 2, leaving you with x plus 1 over x plus 1. And we're left with negative 2. Oh, what's one thing I may ask for? Something I forgot to include in A. The exclusions. Namely, x can't equal 3 or negative 3. If it ever made 0 in a denominator in the problem, must be excluded. So let's just make sure it's enough. See if I cancel out. That's a problem. Or maybe you can see, oh yeah, negative 3 can be 0 in the denominator. It's got to go.
Because it would be with the negative 3 and then it's minus 9. Right?
Well, what is negative 3 squared? 9. 9 minus 9 gives us the undesired result of dividing by 0. Don't do it. Don't divide by 0. You promised, right? Priscilla, I remember you gave the vow of never dividing by 0, and you seem to be sticking by it. Thank you. The puppies appreciate it. X for number 2 can't be equal to negative 1. Yeah. For C, could you foresee this problem? No, probably not. Sorry, that's terrible. Multiply top and bottom of the first one by x. Multiply top and bottom of the second one by 3. I think we're left with x plus 6 over 3x. Is that right? So lots to squeeze in there. I don't know if that makes sense. Any exclusions? Can't equal 0. Okay, I'm going to separate this out a little bit. 6 I'm going to think about as 2 times 3 times x 9 I'm going to think about as 3 times 3, and then x squared, of course, is x times x. So this is educational purposes only. I wouldn't expect you to actually factor that out. But that's just to see what we have to do to the first fraction and the second fraction. Go ahead and discuss for a little bit what are you going to multiply to get the least common denominator and get that final answer. So our goal is to get the denominators to be the same. That's why the first fraction will be multiplied by 3x. It's going to be multiplied by 1 in the form of 3x over 3x. I know I'm being picky. That's what you meant, isn't it? It's what you meant. Make sure you're writing and saying what you mean. So multiplying by 3x over 3x. Whereas the second one, we're going to multiply top and bottom by 2 over 2. And now the denominators are the same? I believe they are. So I'm going to make a summary of the denominator. What is that? Should I just leave it? 2 times 3 squared times x squared. Is that okay? It's not quite simplified. When it's just single numbers, let's actually work that out. It's 18. I think I heard that. Is that right?
Yeah.
And the top is 15x minus 8. Can I do anything with that? I could write it nicer, but that's not what I'm talking about. Yeah, we're done. Just x cannot equal 0. Perhaps you can come forward immediately just multiplying top and bottom of this first fraction by 3x. Yeah, you can just kind of see that thing. I think bottom of the second by 2. It's up to you. If you're ever in doubt, break it down into factors. That is your saving grace. E. I'll write this over so I have a little bit of room to actually do stuff. First fraction, I need to multiply top and bottom by 2. I think that's it. Second one, I need to multiply top and bottom by 5. Does that do it? 5x. Does that do it? Yeah, I think at this point they'll both be 20x cubed on the bottom. A lot of people like to write the entire fraction first, the entire fraction first. I recommend put these together. We already have a common denominator. Why do that extra step? So we have just 14 plus 25x. X cannot equal 0. F. Okay. So I see we have a 2x over here, we have x here. I want this to be a 2x, I just add x to the top and bottom. That'd be a really good way to get 0 and focus on that problem, don't you think? If you're adding something at top and bottom, just add top and bottom. We're going to discuss, what are you going to do that? Add those fractions. Is it possible? Okay, the first fraction, what are we going to do to it? Are we going to multiply by x plus 3? Over x plus 3? Does that make sense? Yeah, in factored form, it's broken down as, did I say breaking down? Oh man. That was a fail. It's broken down as much as possible, so you just use the entire factor. Bottom, x plus 3 times 2x minus 3. Top, see, I really didn't do any work, I just rewrote.
You like to factor all of that down.
Well, could I cancel the 2x minus 3?
And you can also calculate.
Could I do that? Could I recancel 2x minus 3?
Yeah.
The 2x minus 3 is a factor of the bottom. Is it a factor of the top?
No.
What's preventing it from being a factor? The minus sign, right? It's a quantity minus another quantity. It's not factored. It looks factored. It's the number one error in calculus. Because they're not paying attention how to get you. It's kind of something like that. But you won't. You won't. So what can I do? Well, I'll give you a chance to discuss what you can get if you're not canceling. I mean, here, distribute. Yes? Distribute which part?
All the 4 and
The top or bottom? Just the top. The bottom, we're going to leave it alone because it's already factored. Don't touch that denominator. Ava, I saw you trying. I'm watching you. But yeah, top, distribute, simplify, see if you can factor it. I'm just kidding. She wouldn't do a thing like that. Okay, we'll do it right. So on the top, x squared plus 5x plus 6 minus, whoa, that's big, 8x plus 12. I included that danger, but I hope that you're going to put that in your heads anytime you see minus a quantity. Danger lies ahead. Once you're aware of that, it's not a problem. Let's see if I can draw like I'm not a third grader. What's going on here with this? Maybe that would be better. Should I distribute the denominator? No, it's already factored. Okay, so top becomes x squared minus 3x plus 18. Does that factor? There are two numbers that multiply to be 18 and add to be negative 3? Yeah. X minus 6 and x plus 3, is that right? Is it negative 18? What? Where's the negative 18 coming from? Did I do something wrong? Oh, you're isolating. Yes, thank you. I factored incorrectly. So what does it factor to? Does it? Yeah, I don't think that's gonna help. I feel like it should have been factorable. I don't think it's factorable. There are no two numbers that multiply to 18 and add to be negative 3. I was fooled by it, except for Baron's guidance. Thank you, Baron. I could have ended in calamity. Doesn't factor, so nothing cancels. I think we're done. Unless I did something wrong. Which happens. I'm human. Please forgive me. X cannot equal negative 3 or 3 halves. If it doesn't say to include that, you don't have to. I'm just trying to be complete here. You may or you may not. It's not extra. And it is extra. Let's see what you could do for G and H. You're trying to start with G, I'm going to go ahead and do these two. First one, multiply top and bottom by x plus 3, x plus 3. Should I put parentheses on the left side? It would be appropriate. If you leave them out of your work, just proceed with caution. Here I'm going to multiply top and bottom by x minus 3. And the problem with leaving them off is that you might mistakenly only multiply by 3 ultimately. So be careful, please. We're here only multiply by that once. We have a denominator, x plus 3, x minus 3. Top is x squared plus 3x. Not a lot of caution right here, so I can go ahead and distribute x squared. Minus 3x plus 1 is minus 2x minus 3. I hope you don't mind me trying to write to that negative 2. I know that these are pretty much always negative 3x plus x. You may, or you don't have to. So we have 2x squared plus x minus 3 over this guy. Does this one factor? Oh, cool. I don't know if it's going to be helpful, but so it factors into 2x is it plus 3, and then x minus 1. Does that work? Yeah, that works. Did anything cancel? These are some terribly boring problems. There's some satisfaction in canceling. Hopefully that's coming soon. Nothing cancels, so we just put the restrictions. X can't equal plus or minus 3. H, what do you think the first step to do is here? Factor. Why would we factor? So we can get the lowest common denominator. So x plus 3 over x plus 2, x minus 1, plus 2 times x minus 1. Do you see how this is helpful? Did I finish this problem? Oh, we didn't work too hard. On the test, there always people work too hard and just multiply this x squared plus x minus 2. You're not going to do that. I hope. Have you already discussed H with your neighbor? When you're ready to discuss, I'm going to want some help. Okay, this first fraction. Can someone help me out? What should I do? Multiply by x plus 1 over x plus 1. Are we good with that? I like that idea. The second one, we'll multiply top and bottom by x plus 2. Yeah. Does it matter that they're not in the same order? What property says it doesn't matter? Commutative property. Also, a little bit of the associative property. So put them both together and couldn't care less what order they're in. As long as they're the same, x minus 1 times x plus 1 times x plus 2. There's no danger here. I'm going to say x squared plus 4x, so you comfortable with going directly to that 4x? Or you could do 3x plus x if you want. Plus 3 plus 2x plus 4. X squared plus 6x plus 7. Not factorable. But we can write the restrictions. X can't equal plus or minus 1 or negative 2. That's it. Any questions? I think there's a few more for you to try. Just I and J? Oh, okay, I and J. Here's a trick for Dave. I think we've spoken about it. We'll check your neighbor's progress for I. And if you haven't met your neighbor, of course, please introduce yourself. This might be the first time you're talking to them today. Okay, let's talk about I. But before I do that, can I tell you what I just saw? I just saw some beautiful work. I saw some really nice communication. I saw some kind of moments. And I hope that you enjoyed that process, like catching your mistake. I hope you enjoyed it. Because this is a very comfortable time to do that, as opposed to on a test. So make sure that if you just found a mistake, learn from it, and apply the correction next time. So of course, this bottom is x. Did you recognize that it's a perfect square trinomial? If not, perhaps you just factored in, and that's fine too. So here we're going to factor out that 2. I think that's from x minus 5. Who could help me through the rest? Okay, I'll do it. The first fraction just needs to be multiplied by 2 on top and on bottom. So you hook yourself up with a 2 right there. And the second fraction needs to be multiplied by x minus 5, where? Top and bottom. Can I do this? Do you mind if I just do this? Is that comfortable? I like to try to do efficiency of writing. I get to save that digital ink too. Do you notice the danger? Maybe we want to just keep it in parentheses and save that danger for later. I think that's not a bad idea. So x squared, I see minus 4x, I see minus 5x, minus 9x, plus 20. And then we can distribute. Maybe I'll put it into standard form already. This is plus 11x minus 20. Did I do that right? Over this. Now when I see that negative leading coefficient, that negative first coefficient, I'm going to want to factor that out. I'm uncomfortable starting with that negative number or negative quantity. Does this factor at all? Man, they are not giving us satisfying problems. It doesn't factor, so we're done. Just x can't equal 5. For the second one, can we factor x squared plus 8? Actually, never factor the numerator. We're just trying to add these, so we need to factor the denominator. X minus 2, sorry, a minus 2, a plus 2. What should I do with this? 2 minus a. Priscilla? You could. Could you do that? Using the fact that when you have a minus b and multiply that by negative 1, you get b minus a. It flips it. Nice. So I'm going to multiply top and bottom of this by, well, let's see, where can I do this? Negative 1, negative 1. So I have minus, oh, this is ugly, negative a minus 1 over, now I have a minus 2. That was a little bit ugly, but that's okay. Maybe you want to put that negative 1 on the outside, negative 8. Maybe that's better. And maybe even just make this a plus. That's exactly like negative plus. If you wanted to, if you're comfortable doing that, you may. I'm going to play it safe and just see what comes from here. Now I just have to multiply top and bottom by a plus 2, as I know you all were thinking. So now the bottom is a minus 2 and a plus 2. Top is a squared plus 8. Yeah, I'm going to combine that. Plus, and then it's not treacherous here, plus a squared plus 3a plus 2. So 2a squared plus 3a plus 2 does not factor. A cannot equal plus or minus 2. Did I do that right? Does it match yours? Because if it doesn't match, one of us is wrong. It's very rare that a math question would have 2 correct answers. Unless it has 2 answers. Yes. Oh, good question. Yes. Oh, you're saying 8 plus 2 is 10? Is this true? Thank you. Now is it factorable? Good catch, Priscilla. Thank you. It pains me when I see that kind of error on your mistake, on your test. I feel for you. I do. I'm going to start talking again at 52. Now's a good time to stretch. Check for Snapchat. Oh, no one should be sending you Snapchats at this time. Do kids sell Snapchat? Your age, do kids Snapchat? They use it a little bit. Some people. You're more of a Facebook crowd, aren't you? More Facebook here. Facebook. It used to be that all the kids had Facebook. Are any other classrooms this cold, or just cold in general? Like English or history? Just this one? Did you bring a sweatshirt just for this class? That's kind of a cold day. Good timing, Brandon. That's perfect timing. Thank you all for being respectful of the time of finishing that stretch break. We're dealing with something called complex expressions here, or complex fractions. Does that sound familiar? Complex fractions? It just means a fraction that has a fraction in it, like that. I think you could already do this, but I feel like the strategy you may use is too hard. Like on the top, you have to add these together if they have a common denominator. Bottom, split fraction, one fraction. And you can do it that way, but instead what I'm going to do is, I'm just going to get rid. I'm going to clear the denominators, clear the little denominators. How am I going to do that? By multiplying by the only number I can multiply by. What's that number? 1, which means on this big fraction, I'm going to multiply top and bottom by some quantity that will just eliminate all the little denominators. Do you see what that is? You see that multiplying by x top and bottom will just cancel the denominators? The little denominators. You just have to make sure to use which property now that we're multiplying. We're using identity, that's x and x, so just make sure that moving on, you use the distributive property. Don't just multiply that by the fractions, it's got to be the whole top and bottom. The top becomes, quite easily, x plus 1. The bottom becomes x minus 1. Now I cancel the x's, only if you want to get this problem wrong, because we are done. Nice, isn't it? So it could have been much more complicated if you try to get that common denominator, but please avoid that strategy. For this one, I'm going to multiply top and bottom by whatever I need to get rid of the x, the 2, and the 4. So multiply by an x, a 2, and a 4? I think just 4x would do it, wouldn't it? That would cancel everything. 4x, 4x. I also want you to notice I'm kind of writing this a little bit of definitely not heroic. I'm thinking it's 4x over 1 in my mind. Could you finish it? Okay, so here we have 4. Here we have minus 6x on the bottom. We have 4 plus 3x. Can we do anything with this? I don't think so. We could factor the top. Would that help? The point for factoring at this point would be to see if we could simplify, but as the top and bottom don't have any common factors, you can just leave it like that. It's not more simple to factor without any sort of other destination there. Meaning, yes, you could do this, but nothing's changed. If there were 2 on the bottom, 2 as a factor on the bottom, then yes, please factor and cancel. But you can see, looking into the short future, it's not going to happen. So just leave it like that, please. Just put the exclusion. We'll say that x can't equal 0. Is that it? Yeah, any little denominator. Any denominator at all can't have a 0. Right? If you had this 1 over 0 minus 3 halves, you don't want to talk about what happens. So x can't equal 0 or negative 4/3. Is that right? Negative 4/3? If you're not sure, just set up a little equation. Set that equal to 0 equals negative 4x. And that's the other one. X can't equal negative 4/3. I want to talk to you just a little bit about this 3/2 times 4x. I know a lot of students look at this and say 12 divided by 2. Maybe that was you. I'd rather you not do 12 divided by 2. Instead, I want you to do what? Cancel. You see what cancel is? The 2's cancel, leaving us with 3 times 2. Which is the same thing. I don't mind if you think about it the other way, but I'm just trying to streamline for later on when it gets a little bit more complicated. Only 2 more problems. Oh my goodness. Let's do this together. We have some little denominators. If I want to cancel an x plus h, what do I have to multiply by? X plus h. Or h plus x. That is the same thing. Commutative property of addition. X plus h on the top and on the bottom. Is that going to do it? That's not completely doing it. I still need to multiply top and bottom by x. Can you simplify that? Once you're done, check with your neighbor, make sure you got the same thing. Okay. If you notice a danger, we have to use which property? Distributive property, so all of this is going to be multiplied by that first fraction, leaving us with this x. We distribute this, we're left with minus x plus h. Did you survive the danger? Now bottom is hx times x plus h. I just moved the single variables to the left. So top is, what remains on top? Minus 1 over x. Well, that's a problem. Oh. So how do they get it? Here? Yeah. Well, this time this x is cancelled. We have 1 with the minus. Yeah? Multiplying with the fact that the top and bottom is so minus x plus h. This next step may remain in your head, but it is x minus h over hx times x plus h. So what remains is negative h on the top, hx, x plus h on the bottom. Am I done? Almost done. Yeah, Barry? Yeah, when you say take it out, we're talking about canceling. Just cancel the h's because they are both factors. Cancel that h, cancel this h, leaving us with negative 1 over x times x plus h. Should I distribute that denominator? If you really want to, but there's no need. Leave denominators in factored form. It's my advice to you as young people. See if you can do that last one. I bet you could. Check if you don't want to use iCloud or stuff. Okay. Who'd like to help? Did you get it? Do you feel good about this problem? We'll see. Who'd like to talk us through it? Anybody? I know there are a couple of you who'd like to, but maybe holding back, and I could appreciate that. That's okay. I'm going to rewrite the problem, and maybe you did this too, as x minus 3 and x plus 3. I hope that you did that. You see that difference of squares? That should be a very comfortable process for you. When you see a difference of squares, you should have desire to factor it. Now I'm just going to multiply by whatever I need to cancel all the little denominators, meaning I'm going to have to multiply top and bottom by x plus 3. That'll cancel that 1 on top. It'll also cancel a little bit at the bottom. But I also have to multiply by x minus 3. Maybe you'd be comfortable multiplying top and bottom just by x squared minus 9. Because you already know that that's going to work. But again, I like to break it into factors. So the top is we're going to be left with x minus 3 plus 1 over, what's going to happen on the bottom there? Everything cancels out from the first fraction, leaving 2 plus, should I write x squared minus 9? We're not going to have to combine those terms anyway to see if it factors, so it would make sense to do this. Oh, is that right? So I have to actually distribute the whole thing? Oh, thank you for catching that. Should I say plus x squared minus 9? Nice. Woo. Okay. So top, we have x squared plus x minus 12 over x squared minus 7. Should I factor the top? We can, but is it helpful? Looking into the near future, you can see that it's completely not helpful. You can spend a lot of time maybe trying to factor something that is factorable. The body is definitely maybe even obviously not factorable, so what's the point? Except maybe you want to include some exclusions. X can't equal negative 3, so plus or minus 3. Anything else? How do you solve this? X squared minus 7 equals 0. X squared equals 7, so x equals Just positive root 7? Plus or minus root 7, so it can't equal either one of these. And we didn't do the exclusions for this last one, for C. Well, let's see. Yeah, for both of them. So x plus h, let's start with this. This can't equal 0. In other words, x can't equal negative h. And x can't equal zero. Right? No denominator should ever equal 0. Is there anything else? H is a variable. H can't equal 0 or negative x. Yeah, h can't equal negative x. Oh my goodness, so many exclusions there. So what can it equal? What can it equal? Anything else. So today, that was a lot. Are you feeling okay? Is your brain full? Would you please discuss the main takeaways? What's the most important things that we talked about today for you to remember? And I will want to hear some suggestions. So main takeaways. What's one? Yes, Ivy. Thank you. Yeah, be careful when you're distributing with that negative. Good. Anything else? Yes, Priscilla. Yeah, like if you're distributing, distribute the whole way. I like it. What else? Anything else that's important for you to remember? For adding and subtracting fractions, you need common denominators. Make sure the denominator is not too large, and you do that by making sure the denominators are first broken down into factors. For complex fractions, just cancel the little denominators by multiplying by whatever you have to. Next time I see you, you're going to have something else in the room. And next time I see you, I think I'll have met some of your parents, right? Back to school day. Don't leave yet. Don't leave yet. So I'm looking forward to meeting your parents. Next time I see you, just so you know, there will be popsicle sticks in the room. Each popsicle stick will have your name. I was excited. Right, so you guys are quiet, but you have something to offer. So I will be encouraging you to answer questions by drawing your name out of a cup. Just so you know that's coming. So have a great weekend. For those of you who are fasting, I hope it's a meaningful fast. We'll see you next time. See you Tuesday. My pleasure. Emma, I feel like you knew about this.
I didn't know about this.
You had an idea. You had an idea it was coming.
Yeah. Very sad.
You're gonna love it. My pleasure.
I'm not trying to argue my grade, but
My pleasure. The rubric is in the math office. Have you been to the math office? Let's just take a little field trip.